All right, we're going to do something a little different today. Forget just watching. You're an intern. And your first day on the job is a deep dive into the heart of electric vehicles, the batteries. Let's get to it.
So have you ever really wondered what these internships are all about? Beyond the buzzwords, what's the actual work? Well, today, that's you. You're getting a mission, you'll learn the core tech, you'll run the analysis, and you'll even build a professional report. You ready?
Okay, first things first. Every intern gets a mission brief. Let's take a look at your objectives for the day.
Here's the game plan. We're going to start by getting you up to speed on the three big battery chemistries out there: LFP, NMC, and NCA. Then we'll see how a battery cell is actually put together and figure out what makes one good. After that, it's all you. You'll compare these chemistries head-to-head and then wrap it all up in a professional recommendation. Yeah, it's a lot, but by the end, you'll have something real to show for it. All right, let's get to your technical briefing. Look, before you can analyze anything, you have to know the fundamentals. So let's talk EV battery components.
The battery. It's so much more than just the fuel tank of an EV. You have to think of it as its heart, its entire personality, really. The specific chemistry inside that battery casing, that determines literally everything. How far the car can go, how safe you are, what it costs, and how long it's going to last. It is the single most important part of the entire car.
So how do you actually build one of these things? Honestly, it's kind of like making a sandwich. You've got your anode, which is usually graphite. Its job is to hold on to the energy. Then you have the cathode, which is where the magic happens. That's our LFP, NMC, or NCA. In between, you slap a separator to make sure they don't touch, which would be bad. And it's all swimming in an electrolyte that lets the energy flow back and forth. But remember the cathode. That's the secret sauce that changes everything.
As we look at these different chemistries, we're going to judge them on these four things. First, energy density. Simple. More density means more range. Next, cycle life. Basically, how many times can you charge it up before it starts to wear out? Then there's thermal stability. This is a huge one. It's all about safety and preventing fires. And finally, cost. Because if nobody can afford the car, none of the other stuff matters. Keep these four in your head, because this is our scorecard.
Okay, briefing complete. Now for the main event, the analysis. It's time to put these power players head-to-head. First up, we've got LFP. Think of this one as the safe, reliable workhorse. Its superpowers are that it's super stable, so very low fire risk, and it lasts for a really, really long time. The trade-off? The range isn't as high. But here's why it's a big deal. LFP is what's making affordable EVs possible, and that is shaking up the entire car industry. Next, meet NMC. For a long time, this has been the go-to choice for most cars, and for a really good reason. It's all about balance. It gives you great range, but it doesn't have the crazy high price tag of our next option. It's the all-around performer that just works for most people.
And finally, we have NCA. This is the powerhouse. NCA packs a massive punch with super high energy density. That's what gets you that incredible long-range performance you see in premium cars. But all that power has a cost. Literally. It's more expensive, and it needs some pretty sophisticated tech to keep it safe and cool.
Okay, now this is where it all clicks. When you see them side by side, the trade-offs are crystal clear. Look at LFP on the left, maxed out on safety and lifespan, but lower on range. Now jump all the way to the right to NCA, the undisputed champ of energy density, but it's less safe and has a shorter life. And right there in the middle, that's NMC, the great balancer. This shows you there is no single best battery. It's always about the best battery for the job.
If you remember one thing from this whole analysis, make it this. This quote is the perfect elevator pitch. LFP is for going the distance over many years. NMC is for the everyday driver. And NCA is for pushing the limits of performance. That's the kind of clear, simple insight that makes a great report.
So you've crunched the numbers, you've done the analysis. Now for the final step. It's time to create your deliverable and make a recommendation.
So what are you actually handing in? Three things. First, a quick summary of the battery basics we covered. Second, that comparison chart. That's the core of your work. And third, a short 150-word report where you make the call. Which battery goes in a scooter, a regular car, and a high-end EV? This is where you prove you can apply what you've learned.
Okay, assignment's in. Let's finish up with a quick debrief on the skills you just picked up.
If this were a real internship, this is how your work would be judged. And notice something really important. Knowing the tech and doing the comparison is huge. Yeah, that's 60%. But the other 40%, that's about showing you understand why it matters and being able to communicate it clearly. That's a skill that'll take you far.
And you're done! Congratulations! In just the last few minutes, you've picked up real, practical skills in battery chemistry, cell construction, performance analysis, and even professional reporting. So, achievement unlocked! You are now an EV battery analyst level 1.
And that brings us to the end of your first day. But I want to leave you with one final question to chew on, because it's the central dilemma for the entire industry. What's more important for the future? Should we push for the absolute maximum range no matter what? Or should we focus on making batteries that are 100% guaranteed safe? There's no easy answer, but the path we choose will define what our electric future looks like. Thanks for joining me.